6.3 binomial radical expressions. We're going to be adding and subtracting radicals that are binomials, and we're going to also be multiplying and dividing those, and then we'll be also, because we're dividing, we're going to have to rationalize those radicals, because remember, in the previous sections, we cannot have a radical in the denominator. All right, so, get this out of the way. To add or subtract radical expressions, the radical must have the same radicands. The stuff inside has to be the same, and the same index, just like combining like terms. So if you remember, back in Algebra 1, we did 5x plus 3x, and that became a total of 8x. 5 trucks plus 3 trucks is 8 trucks. Those are like terms, but 5x plus 3 is in the simplest form because these are not like terms. Okay, that's going to be the same principle that we're going to be using with radicals. The index must be the same. Everything inside the radical must be the same. So just think of it like a big old variable. All right, so we have 14a times the square root of 7ab plus 5a times the square root of 7ab. Notice that the indexes are the same. They're both understood too. And the radicands is 7ab and 7ab. That means we could put them together. It's like having a variable there. So it really becomes 14a plus 5a, which is 19a, square root of 7ab. Okay, so combining like terms, 14a and 5a make 19a, and then that's times the square root of 7ab. All right? Another example is 3 times the fifth root of x minus the fifth root of 3x. Well, they're both the same index, but the radicand is totally different. So you cannot subtract or add these. These are in simplest form. Okay? And the properties that go along with this, if you have a to the nth root of x plus b to the nth root of x, you can take the a and the b, put it in parentheses, and then times the nth root of x, just like we did up here. Same with subtraction, a to the nth root of x minus b to the nth root of x. We can write the a and the b and subtract them in parentheses, and then times that by n, the square root of x. Nth root of x, sorry. So, for example, get a color that we should be able to see. All right, if we have 3 times the fifth square root of 5x minus 2 times the square root of 5x, okay, the indexes are the same, the radicand is the same, so we can subtract these. So 3 minus 2 is 1. We don't have to put a 1, but you can. And then square root of 5x. Most likely, you're just going to see this written as the square root of 5x. Either one. Same thing. Then you just subtract them. You can have a negative number in front of the radical. That's okay. You may get those. All right, this one is 12 cube roots of 7xy. Subtract 8 cube roots of 7xy. So we look at our index. They're both cubes. And the radicands are the same, so we can subtract 12 minus 8, which is 4, and that'll be the cube root of 7xy. And that's all you can do with those. Those are simplified. All right. Now, when we are multiplying binomial radical expressions, you treat the radical as you would any other term. You're going to distribute, double distribute through the parentheses, and multiplying outsides to outsides and the insides to the insides, and then combine the like radicals and simplify. And simplifying is going to be the name of the game in Algebra 2 this year. You'll hear us say that a lot this year. So we're going to multiply this term to, let's get a different color, multiply this term to this term, and then this term to this term. So we're just double distributing. So what is the square root of 5 times the square root of 2 Multiplying the inside, you get the square root of 10. What is square root of 5 times the square root of 5? Well, that's going to be positive square root of 25. Now, you must simplify. So this is going to become what? 5. Square root of 25 is 5. So this just becomes the square root of 10 plus 5. You don't tag it in front. That means multiplication, okay? You just leave it just like this. All right? Now, we have a binomial times a binomial. That means we're going to double distribute. I'm going to distribute this 5 through first. And then I'm going to distribute the square root of 7 through. Okay, and then I'm going to clean up and simplify. All right, so the square root of 5 times the square root of 3 is the square root of 15. Square root of 5 times the square root of 6 is the square root of 30. The square root of negative square root of 7 times square root of 3 is going to be a negative square root of 21. And negative square roots of 7 times a positive square root of 6 is going to make a negative, and that's going to be the square root of 42. And then you got to go back and clean up if you can. Square root of 15 is broken down as far as it can go. The square root of 30, I don't believe that can be broken down any further either. There's no perfect squares that can come out of either one. Same with the square root of 21. That one's already done. The square root of 42 is 6 and 7, and that's pretty much already broken down. There's nothing else that I can do to that. 4 won't come out, 9 won't come out. So this is broken down. So this happens to be, believe it or not, my final answer. Now, when you multiply radicals, make yourself a note in mental note. You can end up with 4 terms, you can end up with 2 terms, you can end up with 1 term, you can end up with 3. Radicals are not going to be the same for each one. Unlike when we multiplied a binomial times a binomial in factoring, we got, multiplying polynomials, we got a trinomial. That is not going to be the case. You could get 4, 3, 2, or 1 terms, okay, when you're multiplying radicals. So it doesn't matter as long as you check everything to make sure it does not simplify. There's nothing that I could put together. None of the radicands are the same. That's as far as I can go. All right, now a new word, conjugate. We'll be talking about that a lot. Conjugate means a binomial that is identical to another one except for the sign. All right, so for example, the square root of 5 minus the square root of 7 and the square root of 5 plus square root of 7. They're exactly the same, but one's positive, one's negative. These are conjugates. And what we will use these for is to help get rid of radicals on the bottom of division problems. Okay, when you have these kind of things and you're multiplying, you're going to end up with a plain old number as your answer. And you'll see what I'm talking about. This is a reason why you may have 4 terms and sometimes you won't. If you multiply the square root of 5 times the square root of 5, you get the square root of 25. Square root of 5 times a positive square root of 7, you get a positive square root of 35. A negative square root of 7 times 5 will give you the negative square root of 35. And then the last term, negative square root of 7 times a negative square root, positive square root of 7 makes a negative square root of 49. All right, so you clean this up. These in the middle, when you have conjugates, they cancel out, just like it would if it was a difference of squares. All right, the square root of 25 becomes 5. The square root of 49 becomes 7, and it's a negative 7. So that's 5 minus 7, which is negative 2. That is our final answer. So as you can see, you're going to get all sorts of weird things when we're doing radicals. All right, now, when we are dividing binomial radical expressions, remember, you cannot have a radical in the denominator, and therefore you have to rationalize the denominator. If you have a binomial radical expression in the denominator, so it's a binomial in the denominator, you must multiply the numerator and denominator by the conjugate we just learned about of the denominator. Okay, so looking at this example, 3 divided by 4 plus the square root of 2. We must multiply in order to get rid of this mess, because this is really a group. You cannot break them up. Okay? Anytime you have a plus or minus in between two terms, it might be helpful if you use parentheses to show you cannot break them up. All right, so the conjugate of the bottom. If I have a 4 plus the square root of 2, I need to multiply by the opposite, which is 4 minus the square root of 2. And you must do that to the top and bottom, because remember, we can't change the structure of the original problem by doing any of this. This just is really 1, and we can multiply by 1 and without changing the problem at all. So I'm going to multiply the bottom and multiply the top by the conjugate of the bottom. So when I do the top, it's going to be 3 times 4, which is 12. 3 times a negative square root of 2, and that makes negative 3 square roots of 2. The bottom will be 4 times 4, which is 16. 4 times a negative square root of 2 is 4 times a negative square root of 2. 4 times a positive square root of 2 is the plus 4 square root of 2. So you see these will cancel. And you can skip that part if you know that they are conjugates. And then the square root of 2 times the negative. This is important. It's always going to be a negative square root of 2. That makes a negative square root of 4. There will always be a negative on the back end when you're multiplying by conjugates. Okay? So that makes a square root of 4, which becomes 2. So this essentially becomes 16 minus 2. 16 minus 2 is 14. And you see all the radicals are gone, which is what you want. Now, the top cannot be broken up or anything. Remember, it is a group. Okay, so you cannot break that up and, just simplify this part. This is all together as simple as it can be. However, you may end up with problems where you can simplify. All right, so if you end up with an answer such as this one right here, okay, where it says 12 minus 2 square roots of 2, all that divided by 4, the outside numbers, if they have a common factor, you can take that out. They all three have to have a common factor or a common multiple. What's in common between 12, 2, and 4? Of course, you can see they're even, so 2 can come out. So if 2 can come out, you must divide all three of these by 2. All right, now you cannot mess with the stuff on the inside of the radical, the radicand, because that is an inside part. Only insides and insides, outsides and outsides, okay? You cannot do 12 minus 2 because this is one whole part right here, okay? Cannot split that up. So it's 12 divided by 2, which is 6. And then negative 2 divided by 2 is a 1. And notice I didn't write 1. You can put that in there if you want to, but it's not necessary. And then 4 divided by 2 is 2. Okay, so this would be the simplified answer. And this would be what you would find on any kind of test. You would not, if you were doing a multiple choice type test, you would not see it in this format. It will always be in simplest form. Okay, so remember, if you can simplify the outsides and there's something in between all three, then you can take that out. If it's only with 2, you cannot do that. You cannot take the insides with the outsides. Okay? All right. And that is all I have for you. We will practice so many of these in class. So if you have any questions, come see me, and I'll see you in class.